Lesson: Avoiding bias and ensuring ethical outcomes. Avoiding bias and ensuring ethical outcomes in artificial intelligence systems is not only a technical challenge, but also an ethical imperative. As AI technologies increasingly influence decision-making across various sectors, the need for AI systems to be fair, accountable, and transparent becomes paramount. Bias in AI systems can lead to unfair treatment of individuals and groups, resulting in discrimination and inequality. Therefore, professionals tasked with auditing AI systems must employ practical tools and frameworks to identify, mitigate, and prevent bias, ensuring that AI outcomes align with ethical standards. One of the primary steps in avoiding bias in AI systems involves understanding the sources of bias. Bias can be introduced at various stages of AI development, from data collection and model training to deployment and evaluation. For example, if a training dataset lacks diversity or represents historical prejudices, the AI model is likely to perpetuate those biases in its predictions. To address this, auditors can implement data auditing frameworks that evaluate the representativeness and fairness of datasets. Tools such as IBM's AI Fairness 360, an open-source toolkit, offer metrics to assess bias in datasets and machine learning models, providing actionable insights for mitigating bias. Another critical approach to mitigating bias involves employing algorithmic fairness techniques during the model development phase. Techniques such as reweighting, resampling, and adversarial debiasing can be applied to ensure that AI models treat all groups fairly. Reweighting involves adjusting the importance of certain data points during model training to balance the representation of different groups. Adversarial debiasing employs adversarial networks to minimize bias by learning to predict and mitigate potential biases in the data. These techniques can be integrated into AI development workflows to proactively address bias before models are deployed. Moreover, ensuring ethical outcomes in AI systems requires ongoing monitoring and evaluation post-deployment. AI systems operate in dynamic environments where new biases can emerge over time. Therefore, continuous auditing using frameworks such as the fairness, accountability, and transparency in machine learning principles is essential. These principles advocate for regular assessments of AI systems to ensure they remain fair and accountable throughout their lifecycle. Implementing these frameworks enables organizations to detect shifts in model performance and bias, allowing for timely interventions. Transparency is a cornerstone of ethical AI systems, facilitating trust and accountability. Auditors should advocate for explainability in AI models, ensuring that stakeholders understand how decisions are made. Techniques such as local interpretable model-agnostic explanations and Shapley additive explanations offer methods to interpret model predictions, providing insights into the features influencing decisions. By incorporating these tools, auditors can enhance stakeholders' understanding of AI systems, enabling them to identify and address potential ethical concerns. A practical example of the importance of transparency is the case of Compass, an AI system used in the U.S. criminal justice system to predict recidivism. A study by ProPublica revealed that Compass exhibited racial bias, disproportionately predicting higher recidivism rates for African American individuals compared to their white counterparts. This case underscores the need for transparent AI systems where stakeholders can scrutinize and understand the basis for predictions, leading to more equitable outcomes. In addition to technical measures, fostering an ethical AI culture within organizations is crucial. Ethical guidelines and frameworks, such as the European Union's Ethics Guidelines for Trustworthy AI, provide a foundation for embedding ethical considerations into AI development and deployment. These guidelines emphasize principles such as human agency, privacy, and non-discrimination, offering a roadmap for organizations to align their AI practices with ethical standards. Stakeholder engagement is another vital component of ensuring ethical AI outcomes. Involving diverse stakeholders in the AI development process brings varied perspectives, helping identify potential biases and ethical concerns. Techniques such as participatory design and co-creation workshops facilitate collaboration between AI developers, users, and affected communities, ensuring that AI systems address the needs and values of all stakeholders. By fostering inclusive engagement, organizations can create AI systems that are more aligned with societal values and ethical norms. The integration of ethical considerations into AI auditing also requires a multidisciplinary approach. Auditors should collaborate with ethicists, sociologists, and legal experts to gain comprehensive insights into the potential ethical implications of AI systems. This multidisciplinary collaboration enables a holistic assessment of AI systems, ensuring that ethical concerns are addressed from multiple perspectives. Furthermore, organizations can leverage ethical AI frameworks, such as the AI Ethics Impact Assessment, to systematically evaluate the ethical implications of AI systems. The AIEIA framework provides a structured approach to assess potential ethical risks, offering guidance on how to mitigate them before deployment. By incorporating such frameworks, AI auditors can enhance their proficiency in identifying and addressing ethical concerns, ensuring that AI systems are developed and deployed responsibly. Statistics demonstrate the tangible benefits of implementing ethical AI practices. A study by McKinsey & Company found that organizations prioritizing ethical AI practices reported higher levels of trust from consumers and stakeholders, leading to increased adoption and satisfaction. This reinforces the notion that ethical AI practices are not only morally imperative, but also beneficial for business outcomes. In conclusion, avoiding bias and ensuring ethical outcomes in AI systems requires a comprehensive approach that integrates technical tools, ethical guidelines, stakeholder engagement, and multidisciplinary collaboration. By understanding the sources of bias and employing algorithmic fairness techniques, auditors can mitigate bias during AI development. Continuous monitoring and transparency further enhance the accountability of AI systems, while ethical guidelines and frameworks provide a foundation for aligning AI practices with societal values. Engaging diverse stakeholders and leveraging multidisciplinary insights ensure that AI systems address the needs and values of all communities. Ultimately, by prioritizing ethical considerations, organizations can foster trust in AI systems, leading to more equitable and responsible AI outcomes.